going through the Ultimate Go Tour here, and we're going to learn about structs here. And in particular, what we're going to learn about is if you want to go to the Go Tour, go to tour.ardenlabs.com/tour/list, that place right there. And then here is what we're going to see in this video. If you come to Goes to 11 at GitHub and click on repositories, for those of you who haven't been watching the series, it's a series of videos. There's a link to the playlist down in the description, so you could go through like all of the videos where we go through all of the steps. But here at GitHub Goes to 11, go to repositories, go to the Learn to Code Go version 3 repo right there, that one. And then scroll down through all these 0 folders, 0, 0, 0s. These are just like my working folders. And then sequentially it starts to go up in a way which will teach you Go in an incremental fashion. But right now we're working in this folder right here, 000 BRBK Go Tour. So you could click on that link and it'll bring you into this amazing README file and series of README files. And I spent most of Saturday putting this together. And so there's a table of content for all the different videos, and then each video is right here along with the README. So this is one more way you could do it and go through all these different videos. And so these each correspond to a step in this Go Tour. And there's a video that explains what's going on. That's what you're watching here is one of those videos. And there's also a README that explains what's going on. So I'm going to open this in a new tab. But before I do that, I just want to point out here at this root level of the 000 BRBK Go Tour, there's also going to be a code review check where highlights for code reviews are put in. And those are just great little things to kind of look at and think about. And so here's the README for the video we're going to cover today, and here are the key takeaways, and there's the table of contents. And we're going to learn a couple of important things here. You can see those takeaways there. But one of the important advanced concepts, we're going to have an advanced concept that we're going to learn, and also we're going to cover beginner fundamentals. So good for everybody. But the advanced concept here is when you're working with structs, the Go compiler will optimize your struct by adding padding bytes, and this is known as alignment. So alignment, padding bytes, and mechanical sympathy is what you're going to learn about in this video. And so the Go compiler will optimize your structs by adding padding bytes. So those padding bytes help your struct align with the machine it's running on so that it fits into memory well and it fits in with the processing of the machine, processing bytes and word sizes, 8 bytes, 64 bits at a time on a 64-bit machine. So we're going to learn about that in this video. And so the first thing I guess I'll start with is just with language mechanics. And so for language mechanics, we're going to come over to VS Code here. And in VS Code, we're just going to go through some of the mechanics of working with a struct, and we'll just highlight those here: struct literal, anonymous struct, and the zero value. And so to create a struct literal, this is what that would look like, right? We could define a new type, a new data structure. This is type person. We're creating a type. Go is all about type. We create values of a certain type. It's strictly type. Type is life, Bill Kennedy would say. So we're creating a new type, which is interesting. It's super interesting. We create a new type, and the underlying type of type person is a struct. And so this is a new data structure, and it has two fields, name and age. And name is going to store a value of type string, and age will store a value of type int. And then we could come down here and we could use a struct literal to create a person. And so we could do it in all of these ways right here, right? But this is kind of like the preferred way when you're just getting started, just so you understand it. And you need to have a trailing comma right there, right? But we do name, and then we do age, and then, right, we have a new value of type person that we can use. And we could also do an anonymous struct like this, where we just don't give the struct, right? Like we don't say it's of a certain type. We just say it's a struct. It's an anonymous struct. And so this one here is of type person, and the underlying type is a struct. Here is just, it's a struct, right? And it's no type person or anything. It's just a struct. So it's an anonymous struct. It's going to have two fields, x and y. They're both going to be ints. And then at the same time, we're initializing this for x to have the value 10 stored to it, and 20, and y to have the value 20, and we're assigning that to point. And then we could print that out, calling with dot notation, point dot x, point dot y. So let's see that in action. We're just going to write some code. We're going to see about Go modules, and we're also going to see about packages. And to do that, we're going to come into VS Code, and I'm going to show you something amazing at the advanced level coming up here. There's a field alignment analyzer, which I'm going to show you. So that's coming. And if you want, you could just kind of scrub that playhead to jump ahead and try to find that point in the video where I talk about that if you just want to see that. But to do these basic mechanics of working with structs, I'm going to create a new package, and I'll call this package class example. And so creating a folder class example, and then inside there I'm going to create a file class x.go, and then I'm going to call this package class x. And so now I can work with this package, and to work with it I need to import it. And to import it, I want to go down and look at my Go mod file. And so down in my Go mod file, I'll see what my module is called. So this repo here, it's called my module. And then I can just come back up here to my main file. And in my main file right here, if I want to use that class X package, I need to import it from my module. So I already have one module here that I'm importing, those pointer value semantics, which we'll look at in a second. And to import this next one, I just kind of changed the path there to class X, and now class X is ready to be worked with. So inside class X, I could start creating some code. I'm just going to do a func run me here at first, and I'm going to just say func.println, and I'm going to say this is from run me. I guess we'll spell it the same, and I'll just put a few lines on each side of it, and then I'll also just have sort of, you know, an ending. I'll have an ending line at the end of it. Wow, my pace just really changed there in my speaking. How do you like that? And this is the end. This is the end from run me. So we'll have that, and then Command S will bring in my imports. And because I've capitalized run me, this is going to be available outside of the package. So it'll be visible outside the package. It'll be exported from the package. We don't say public and private in Go. We say visible, not visible, exported, not exported. But capitalization determines whether or not something's exported from a package. So if I come back over here and I just go to main, and I'll do a little comment here, live coding. And if I do from class X, right, I now have run me, right? And so that run me is there. And if I, you know, put in another function here, so let's just copy this and paste that down. And so if I had func internal something internal, and that's lowercase, right? And here in something internal, I could just say this is internal. And just to show you kind of like how packages work, and I'll delete all that. There we go. Satellite radio. And now I have something internal. If I come over here to main.go and I say, okay, let's run that something internal, right? Class X dot, and it only has run me. Something internal is not visible outside of, you know, the package, because I didn't make this capital. But if I made that capital, just FYI, right, I can now come over here and do class X, and something internal is now visible outside the package. It's exported from the package. I want that internal, and if I wanted to, I could come up here and I could do something internal, and I could run that right there, kind of cool. And then if I ran all of this, so come over to the command line and go run main.go, you can see up at the top, this is from run me. This is internal, so that ran internally when run me was pulled out and run, and this is the end from run me right there. So that's kind of interesting. So let's look at creating structs, shall we? So we're going to create our own type, and I'm going to create a type, and I'll do a type person, and the underlying type will be a struct, and I want to be able to access stuff. So like, person doesn't need to be accessed outside, but I'm just going to make everything capital here just for consistency. But I might think about whether or not I want a person to be visible outside the struct or outside the package. And if I wanted person to be visible and exported from the package, I need it to be capitalized. Or I might think about having an internal. So a person will have a first name. A person will also have an age. And so then we could come down here and we could create values of type person. And so, you know, I could have, you know, P1 is colon equal to value of type person, capital P, and then these curly braces, and here we're using a struct literal, and this struct literal is going to have inside of it a field first, and we'll make this first one Jenny, and then we'll have an age, and we'll make the age 27. And then I could print out that struct right here like that, P1, and then save that, and then I could come over here and I could run it, clear it all out, go run main.go, And you can see here, I've got Jenny 27 printed out. And then if I wanted to add another struct, I could do struct, I could embed one struct in another struct. So if I had secret agent, right, and that's a struct, I could say a secret agent is a person, right? So they are a person. So they have everything that a person has, and then they're going to have some other stuff. Like they're going to have a license to kill, and that will be a bool. It'll either be true or false. And so if I wanted to create a secret agent, I could do like, essay, which is a Spanish word, I think. I don't know what it means. We could do a secret agent, essay. We could do a secret agent, and a secret agent will be a human. And so a human will be that struct, and then we'll have a comma, and then they'll have a license to kill, and that will be true. And then this person here will populate these fields, will be James, and then the age of James will be like, I don't know, what do we make Jenny 27? James will be 32, and then save that. And I've got some sort of a syntax error going on, but first I'm just going to do this and do a secret agent 1, print that out. And so if I take a look at this, a secret agent is a human, is a person. That's what I needed. They're a person. There we go. Person, they're a person. There we go. So secret agent is a person, and that person has a first name of James and age of 32, and they have a license to kill, true. And now we can print that out. If we come over to our code and we run it, run that, we're going to see that print out. So we have James 32, true. And you might ask yourself, what if you had, you could also use dot notation. So let me just show you that. And so we could say, hey, here's dot first name, and just bring out the first name. Or we could say, hey, here's dot age, and just bring out the age. And then we could also do, right, here's their license to kill, right? And so we could print all that out and just see that run. And that's called inner type promotion. So James 32, true right there. That's called inner type promotion. And so, right, the inner types of type person, the inner type, and person's the inner type, secret agent's the outer type, and the inner types get promoted to the outer type. And so the inner types that got promoted to the outer type were first and age. And so you might, so you could just call that stuff with dot notation. And you can also add methods. We'll see that in just a second. But I'm just checking my time here, 12:41. Doing pretty good for 12 minutes. It's a lot of content. And so then, right, like the next thing to look at is like, what if you had field collision? What if there was a first in the outer type, and that was also a string, and then there was also like age in the outer type as a field, right? So the outer type is secret agent, and the inner type is person. Well, now which first is in age is going to be called when I do this dot notation? And so this is off of secret agent, right? It's off of the type secret agent, so it's going to call out the first and age of the secret agent. So just to illustrate this, I'm going to do a Control C. And so let's say the secret agent name is James, and he says his name is James and his age is 32, but really his name is Joe. Like that's his person name, and he's really 39, because all secret agents lie, don't they? Right? And so like as a person, he's Joe and he's 39, but as a secret agent, right, he's James and he's 32. And so we're going to see here James and 32 is going to print out. So just to see that again, that's kind of funny. And James and 32 printed out, right? The secret agent stuff. And if we wanted to see like the human stuff, we could like, copy these down just one more. And we could say, just show me the person stuff, right? And we could drill down to person, and we'll do first. And we could also drill down to person here, and we could do age here, right? And so now we're being specific. It's like, give me first that is part of the inner type, and give me age from the inner type. And then here is first from an age from the outer type. So we're going to see Joe 39 and then James 32 when that prints out. So let's just take a look at that. And Joe 39 and James 32. So that's inner type promotion. That's embedding one type in another type. It could give you that is a has a relationship. So secret agent is a person, or a vehicle has a engine, right? And so you could embed one struct in another type, in another struct, and get inner type promotion. And that also works with methods. So we could attach methods also to each of these structs, but that starts to take us a little bit away of what the focus of this video is. which is working with structs, and that gives you an introduction to the mechanics of structs. So now, and I'll put a link, I guess, you know, it's a little bit late to say this, but I'll put a time code down in the description to like jump to the advanced stuff. This is the advanced stuff right here. So now we're gonna learn about, alignment, padding bytes, and mechanical sympathy. Because when you create a struct, so I'm just gonna close this example here, and when you create a struct, and let's say that we're creating this struct right here, right? So it's just an example struct, and this is gonna store a bool, an int, and a float 32. And when you create one to create mechanical sympathy with the hardware, right, the Go compiler will add padding bytes. And so this is a micro optimization. And if you look at the takeaways from, today, the takeaways from today, ladies and gentlemen, are first, there's this great quote here about like order the fields in your struct in a logical way that makes sense for readability and not in terms of padding. But if we ever found ourselves in a situation where we need to reduce the amount of memory we were allocating, now this understanding of padding can allow us to do some form of micro optimization. That's Bill Kennedy, right? And so, right, you can order your fields in a way which will allow you to, reduce the size of them. And I'm going to show you a tool to help identify some that could have their size reduced. But and another friend of mine who's a genius with Go that I'm leaving anonymous here said, here's the reality, I don't care about any of this stuff, but at the same time, it's good to know this stuff. And it shows knowledge about the Go programming language, and it can be useful in certain situations, particularly like if you're working with CGO and you really need to think about, alignment and all of that, then this could work. But the main takeaways here is not, if you do need to sort of optimize a struct, the best way to get your padding, to get rid of your padding is to order your fields from largest to smallest. And then another takeaway here is to optimize for readability, right? So optimizing for readability means that we order our fields in a way which is readable, right? Like, first and age is readable. First age license to kill is readable, right? So that's how you would optimize for readability. But just so you understand padding bytes and how that all works, like, if you think about the architecture of a computer has a word size. And so the word size is how many bits can it process at one time. And so most modern computers are a word size of 64 bits. And so they process each operation 64 bits. And older computers are 32 bits. That was their word size. So on a 64-bit computer, that's 8 bytes, right? That's 8 bytes. And so it's dealing with like bytes and 8 bytes at a time is how a computer's dealing with things. And so when you put data in here that has different storage requirements, that data, the compiler is going to look at that data and see how much memory, how many bytes is it going to require. And it's going to use up a certain amount of bytes for that data, and it's going to use them in a certain way to align well with the machine. So let me show you what that means. And so here, the bool is 1 byte, right? And then int62 is 2 bytes, and a float 32 is 4 bytes. And so to make this as readable as possible for the machine, it's going to add padding of 1 byte right here. So padding of 1 byte will be added right here. And so the bool will start in byte position 0, right? And then this one will start after those 2 bytes have been used. This will start at positions, an int62 will start at 0, position 2, position 4, position 6. Right, so that's where int62 will start, and a float 32 will start at position 0 or position 4. And so we could see what that looks like by looking at the line of function from the unsafe package. And so if you come into this README here, and in here we have the table of contents, and down here there's understanding the line of function, along with some other really cool stuff. And so just to look at this table of contents here, struct literal, anonymous struct, 0 value, we went over that. Methods, right? You can take a preview of that. There's a method set preview in here and talks about method sets. And just a key takeaway from that is that method sets are all about interface implementation. And so I'll show you something about that coming up, just a preview of it. And for those of you with more of that advanced mindset. And then we have embedding types and inner type promotion. And so we already saw that. And we have composite, and you could read more about it there. And composite types and aggregate types. So just making a differentiation between composite types and aggregate types. So a composite type is an aggregate type, but an aggregate type isn't a composite type. But those words are used interchangeably, and a composite type is the terminology we use in Go for a struct, right? And so that gives you a little bit of information about that. And then there's mechanical sympathy, alignment, and padding in bytes. And so we'll look through that here a little bit. And there's CPU cycles and CPU operations, just so you could differentiate between those. And understanding the line of function, and then the field alignment analysis tool, and then code review, and then some coupons for Go courses. So understanding the line of function, if we come down to that one, and I just need to like click on something else, and then go back and click on that so it reloads. It's just the way it works. Understanding the line of function, there we go. And so here we have like var x, var y, and var z, and 32, and 64, float 64, and we use a line of on those, and we get 4, 8, and 8. And the 32 needs to be stored at byte location 0 or 4 in a word, right? A word is 8 bytes. And so the 32 is going to take up 4 bytes, meaning it's going to be stored at position 0 or position 4. The N64 is going to be stored at position 0. And so when we run our code over here, and you could see, right, like 4, to kind of align well with how the machine operates, 4 bytes will be at position 0 or 4. An N62 is 2 bytes, it'll be at position 0, 2, 4, or 6, right? Bool can be at any position, but then it'll have padding bytes added after it. So when we run this code and we look at like where's the alignment of a bool, and Int16 and float 32, or of this entire struct, this example, what is the size of that entire, right, amount of bytes used to store all of that? What is the size of that? If we come over and look at this, and so we've already run this, we have this first example here, and tells you a bool can be like any one position. So 0, 1, 2, 3, 4, 5, 6, 7, zero-based index. An Int16 could be 0, 2, a 4, or 6. A float 32 can be 0 or a 4 because it's 4 bytes. And then the alignment of the example, right, is either a 0 or a 4 also. And so the example is that entire right here, a line of A, and it's all of that right there. And then the size of the example is 8. And so this becomes interesting when we look at like unoptimized versus optimized. And so if we look at and there's more examples in here just so you could experiment and explore with it. But if you look at like, unoptimized versus optimized, and in the unoptimized, we have a bool, we have a float, and we have an Int32. And so since this needs to start on position 0, right? To get to position 0, 7 bytes of padding are added between A and B. And then this is like the next, word of 8 bytes. So this will be 8 bytes with its 7 bytes of padding. This will be 8 bytes. And then this is 4 bytes, but then 4 bytes get added to that just as padding to kind of complete it. And so the entire size of this is going to be 8, 8, and 8, or 24 bytes. And so we could see that size right there. It's 24 bytes. But when we optimize this, and instead we go, hey, the large one's going to be at the top. That's 8 bytes. And then we're going to have this 4 bytes, which could start position 0 or 8. So that's going to start position 0 because here's the first word. And then here's like, the next word. And at position 0, we're going to have these 4 bytes starting. And then this could start right after that. And then we'll have 3 bytes of padding after this one because it's 8, and then that's the first word, and then for the next word it's going to be 4, 5, and 3 bytes of padding is another 8 bytes, and so that's going to just be 2 words or 2 chunks of 8 bytes, or it's going to be 16 bytes. So we trimmed off 8 bytes by just optimizing that. But again, right, micro optimization, and that's what my friend, right, who's a genius in the Go programming language said, I don't really care about any of this stuff, meaning like you don't really worry about optimizing in that way, but it's also nice to know. And this person definitely is also very conversant with that. And so, and that's why you also like the takeaway here is optimize for readability, right? That's the takeaway. And the language mechanics, we saw that, right? How to create a struct, that's also a takeaway. And then also, right, the best way to get rid of your padding is to order your fields from largest to smallest. And so that's what we did here, and we shaved off a byte. So you only use this if you need to use it. So these are guidelines, and there are exceptions to everything. So that's another takeaway. So just to point out these last 2 takeaways, I guess I'll come back to these. And the next thing I'll show you is this optimization tool. And so in here, there's an optimization tool. And if you go and you look at like, the notes on field alignment analysis tool, you can check that out. And it'll take you to this package here and the golang.org x tools area. And in this package, you could download all this code and you can install it. And I have some notes here about what this does. And then you could find some more notes here in 4B main. And I need main.go because that's the executable. And so some more notes here about how to run it. But you basically just take that code and put it in here and build it. And it's this code here, put it in here and build it. And then when you build it, you can start analyzing packages. So let's see what that tells us. So I'm just going to do a Command K here and CD up a level and go into 04B. And in here, I'm going to do, I want to run this main executable. So if I look at what's in there, I've got main, which is the executable, and main.go, which is the Go file. And so if I'm going to run main, I do that. And I want it to analyze in 04A. Main.go. I wanted to analyze that file. I'm just checking my time here. And when I run this and analyze it, it tells me at line 106, right, struct of size 24 could be 16. That's pretty cool. And so that's a nice little linter if you want to add that into your tool chain just to see if there's something big that jumps out. You might optimize that. But here at line 106, right, line 106 right there, line 106 right here, this struct is 24 and it could be 16. So that's a nice little tool right there. All right, so the next takeaways, I'm just looking at my time. I've got like 2 minutes before I guess I'm just gonna restart my camera, hold on. All right, just restarted. Now we have all the time in the world. So it's better than running out of tape. All right, so the next thing to point out here is the use of value semantics versus pointer semantics. So these are just previews of what's common in this Go Ultimate Tour and method sets. And so first, I just want to really point out method sets are the methods used for interface implementation. So if you're dealing with value semantics and you have a value just that's a normal value and not a pointer, then only the methods that have value receivers are going to determine whether or not an interface is implemented. So method sets are all about interface implementation. And if you're dealing with pointer semantics, and so you have a value which is a pointer, and then it has methods attached to it, either methods can determine whether or not an interface is implemented. So it could either be pointer methods with pointer receivers or value receivers. And so that's value semantics versus pointer semantics. We're going to learn more about this, but also use value semantics as much as possible when you're coding in Go, because one of the main important things about Go is readability. And so stick with value semantics as much as you can. It's going to make your code more readable, and you're going to have less heap allocations, which is going to make your code more performant. And so a lot of people will jump into pointer semantics quickly just because they want to be able to mutate values, but you could still do mutations by returning and reassigning. That stuff we'll learn coming up. And so really consider whether or not you're going to jump into pointer semantics and stay with value semantics for as long as possible. And just to illustrate that, there's a little code sample here that you could take a look at. And that code sample is pointer value semantics. And so if we look at this here, we have a type person struct. And that's kind of interesting. We have a person from each package. And then we have this value receiver here. So this is creating a method that will be attached to any value of type person. They will also have this method describe. And then we also have a method is an adult, which will be attached to any value which is of type person. So they'll have these methods available. And then we also have runs pointer, which has a pointer receiver, right? So there's a pointer receiver, and we'll learn about pointers. If that's foreign to you, just hang in here. You're just getting some exposure. Don't need to know it now. That'll come up. We'll explain it all. But we have a person here, right? And that's a pointer receiver. And then if you come down here and you use value semantics, so you create a value of type person, right? Using value semantics, not using any addresses here, like all those methods are available to value of type person, right? It runs the pointer, it runs age, it runs it all. And I'm just showing here how age may or may not change. And or it does change here, right? How it does change here. And then if we're using pointer semantics, so down here using pointer semantics, you could see that pointer semantics. Pointer semantics will also run all of these methods, and everything runs fine. And so when you look at this in our code, right? And so in our main.go here, I'm just looking for where we deal with the value semantics and pointer semantics. And so here we have live coding and anonymous struct, and then fumped print line P1, P2, and we have example 1, 2, 3, 4, and pointer semantics, pointer value semantics. This runs right at the end. And so pointer value semantics right here, all this runs at the end. And so if we look at that code at the end, and I'll just cd up a level and go back into 04A and Command K to clear that. That's a Mac command. If you're on Windows, type in clear, Command K won't work. And then I'm going to press enter and then go run main.go once more. And we can see here, after all this optimization stuff, we have value semantics, and you can see like it's all running, right? 32 goes to 33, 27 goes to 28, and so it's all running. So the point of all of that is to illustrate kind of gotcha misconception that happens for a lot of people. And what that's illustrating is that the method set, right, like regardless of whether you're using value or pointer semantics to create values of a certain type, right? The method set isn't which, you know, if you have a value, like here I had a value, here I had a value of type person, value semantics, here I had a value of type pointer to a person, right? Both types of methods were available to whether or not I had a value of type person or value of type pointer to a person, right? They could use either value semantics or pointer semantics as the receivers, right? And so that just illustrates that this misconception that people have that method sets are about, you know, here can only implement methods with the receiver of using value semantics. It will implement either methods with receivers, value or pointer semantics. Same here, value or pointer semantics. But when you're implementing interfaces, what a method set determines is whether or not the interface is implemented. And so it's only going to look at, if you're using value semantics, it's only going to look at receivers with value semantics. So if you're using pointer semantics, it'll look at receivers with value semantics and pointer semantics to determine interface implementation. So that's also you know, something that you'll learn more of coming up as we go through this series. All right, so that's this video here. If you enjoyed this video, leave a comment down below, just say hello. Really, seriously, it makes my day just to hear from people that this is valuable to them. And it motivates me. That's why I became a teacher. I like helping people. Also, if you want to learn more, right, there are complete courses that you could go through. So my courses teach the beginner to intermediate with some advanced, and you can find those courses by just right down here at the bottom of each of these readmes, right? Todd McLeod courses. You could click that link. It'll take you to it. And you could go to Bill Kennedy's courses right here. My dogs are saying hello to us. And for some reason that downloaded. Now it's, why? Okay, there it goes, just opened up. So if you come here to Art and Labs, and it opened up because I'm logged in. But if you come here, and I'm going to open this in an incognito window, and open that up, it's going to bring you in here to a bundle of Go courses, and you could enter a discount code here of Todd McLeod, and you'll get a surprise discount. So those are the courses you could take if you want to check those out. All right, that's a bit about alignment, padding bytes, and mechanical sympathy, and structs, and the mechanics of structs. And there's a lot more here you could read about to deepen your knowledge, but that's this next step in the Go tour. And just so we could see what that looks like here, there's also some more information that you could read about over here. Good to go through, but you know, and some visuals here to help you visualize those padding bytes. And in the next video, we're going to do this coding together with this coding exercise right here. See you in the next video.